Today we're going to learn about permutations and combinations. You should have these notes in front of you. And our first learning target is I can determine the number of possible outcomes using the fundamental counting principle. So if we look at this first activity, maybe you buy a new car. Congratulations. There are 2 body styles, a sedan or a hatchback that you can choose from, and 5 colors. There are 3 models of these cars, a GL, SS, and an SL. And I'm wondering, how many choices do you have for your new car? So when you think about these probability questions, I said it's often best to organize the problem using a tree diagram. So down below you see a tree diagram. So we can have these 2 versions of the car, and we can count out all of our options down here. So when we're building the tree diagram, it can be time consuming. I'm going to show you a way to not have to count so many. But if we count all these options on the bottom, so this first option represents a sedan that's black and it's a GL. Then we could have a sedan that's black and an SS, a sedan that's black and an SL. So we have 30 of these little letters on the bottom. But our fundamental counting principle will show us another way to do this. If there are X ways to complete one task and Y ways to complete another, then there are X times Y total ways to complete a task or possible outcomes. Tree diagrams can clearly show all possible outcomes, but the fundamental counting principle is easier and faster. So the fundamental counting principle is also known as the multiplication rule. So if we look back up at the car example, how many choices do you have? We could multiply that out. We could say there are 2 choices for the body style, sedan or hatchback. There are 5 colors available, and there are 3 models. So 2 times 5 times 3 gives us 30. So without having to count, we can get it a lot faster. So I'm going to pause this video and switch you over to page 2.